Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Muhammad Azim Muzahid. My supervisor is Engineer Swedi James Dipto. I will be presenting my poster, which is simulation analysis on fire performance of steel plate using LS-Dyna. Both me and my supervisor from Department of Civil Engineering in University Pertahanan Nasional Malaysia. In the study, I will use steel plate as the medical fire testing using three different thickness, which is 6 mm, 10 mm, and 20 mm, and three different type of steel, which is from the ASTM standard, A131, A322, and 304. In this study, I will simulate the finding using the LS-Dyna because this software can reduce the amount of work that the previous researcher had to do in experimental study. So in this software, I'll use the thermal isotropic material model, which is can develop to three types of fire curves, which is external fire curve, ISO 834, and hydrocarbon fire curve. The outcome will be validated through simulation and previous literature. In this study, we can see that a comparison time temperature curve between different thickness show that thicker steel plates is a bit more resistant and are effective against heat transfer. Then we move to the problem statement. Many experimental results show that the steel plate will undergo deformation and strength deterioration when exposed to fire. In this case, many researchers had to spend a lot of money to redo the experiment to get an accurate result. Due to that, software such as LS-Dyna can reduce cost to simulate the experiment. My objective is to, in this study, my objective is to determine the fire performance of steel plate with different type of steel when exposed to fire. I also want to analyze the fire performance of steel plate using LS-Dyna finite element modeling, and I will repeat the finding or outcome with previous simulation and experimental result. In the methodology, we start with literature review, pre-processing, simulation, post-processing, validation, data analysis, and writing. To get the simulation result, first we have to define the model using key manager or always known as keyword, then boundary condition. Then we have to run the simulation in LS-Run. Then we transfer the simulation result from the LSP post to Excel Microsoft to get a graph. Then we move to my result, which is from temperature. We can see that at 5, 20 minutes and 30 minutes is a bit different type of heat transfer. This is the steel plate we are exposed to 100 mm radius from the center and upper surface. Then relation of result, I compare with first I compare with the previous study. They use the model of PFA material, the isolation to the steel, which is exhibit the different curve, but at the end of the simulation, we present the same temperature. Then for the second relation, I use a direct fire, which is full fire test. You can see that the agreement can be found between two graphs. Then we move to the fire performance, which is the external curve, hydrocarbon curve, and standard ISO curve. As I said before, I use three types of steel, which is A131 for A, A322 for C, 304 for S, which is 6, 10, and 20 relative the steel thickness. You can see that the thickness play the important role in influencing the heat transfer in the steel plate. So we conclude that the research aimed to investigate the fire performance of steel plate with different thickness and type of steel using LS-Dyna finite element modeling was achieved. The simulation result were compared with previous study and validated through data analysis. The findings highlight the influence of plate thickness on temperature regulation during both external and hydrocarbon fire exposure. This is a reference on my study. Thank you for your participation. I hope you understand what I give you just now. Thank you.